Hi friends, welcome to all. In this video we are going to see the lab activity configuring basic router settings with the iOS CLI. We are going to implement this lab activity in our packet tracer. Here we can see our topology and addressing table. We are going to design this topology in our packet tracer here. So before that, here we can see our requirements. One router Cisco 1941 with Cisco iOS release 15.2, one switch, two PCs, console cables, or we can because we are using packet tracer, we can configure directly using CLI. Then Ethernet cables, right? So we will design this topology into our packet tracer. Coming to the design, router 1941, switch 2960, then the PCs, we are going to connect these devices using copper straight through. So we are going to connect from fast Ethernet 0/6 to this PC, then from fast Ethernet 0/5 to the router gigabit Ethernet 0/0, gigabit Ethernet 0/1. Yes, we made mistake, so here we can change the connection as specified in our topology. Here we are going to connect from gigabit Ethernet 0/1 to fast Ethernet 0/5, then to this PC from gigabit Ethernet 0/0 to this PC. Also, we will rename the devices as per the topology in our activity. So this is a PC-A. Here we have S1, and this is a router, this is R1, and here we have PCB. Also we will mark the interface. It's a fast Ethernet 0/6, and this is a fast Ethernet 0/5. Here we have a gigabit Ethernet 0/1. Here we have a gigabit Ethernet 0/0. Before going to the configuration, we will go through the objectives of this lab. Part 1, set up the topology and initialize devices, cable equipment to match the network topology, initialize and restart the router and switch. So we already designed this topology in our packet tracer. Coming to part 2, configure devices and verify connectivity, assign static IPv4 information to the PC interfaces, configure basic router settings, verify network connectivity, configure the router for SSH. In part 3, display router information, retrieve hardware and software information from the router, interpret the output from the startup configuration, interpret the output from the routing table, verify the status of the interfaces. In part 4, configure IPv6 and to verify connectivity. Also, we will have a look into this background. This is a comprehensive lab to review previously covered iOS router commands. In parts 1 and 2, you will cable the equipment and complete basic configurations and IPv4 interface settings on the router. In part 3, you will use SSH to connect to the router or remotely and utilize iOS commands to retrieve information from the device to answer questions about the router. In part 4, you will configure IPv6 on the router so that PCB can acquire an IP address and then verify connectivity. Now we will come to part 2, configure devices and verify connectivity. Configure the PC interfaces. Configure the IP address, subnet to mask and default gateway settings on PCA, also on PCB. In our addressing table, here we can see the IP address of PCA and PCB. For PCA 192.168.1.3, here we can see the subnet to mask and default gateway. For the PCB, here we can see 0.3 on the subnet to mask and default gateway. We will set this first of all. Coming to PCA desktop IP configuration, here we are going to configure 192.168.1.3 subnet to mask. Now we are going to configure the default gateway. It's 192.168.1.1. Now we will configure on PCB desktop IP configuration. IP address is 192.168.0.3. Coming to the default gateway, it's 0.1. Coming to step 2, configure the router. Console into the router and enable privileged exec mode. So here we can see we are going to assign a device name to the router as R1. So we will set that. Would you like to enter the initial configuration dialog? No. Enable configure terminal. Here we are going to set the host name as R1. Next is a disable DNS lookup to prevent the router from attempting to translate incorrectly entered commands as though they were host names. So we are going to give this command no IP domain lookup. No IP domain lookup. Next is require that a minimum of 10 characters be used for all passwords. So here we are going to give security passwords min-length 10. Coming to the router, here we are going to give security passwords min length. Here we are going to give, we can give the length from 0 to 16, minimum length of all user enabled passwords. So here as specified, we are going to give 10. Here we can see beside settings a minimum length, list other ways to strengthen passwords. Obviously here we given a minimum length of 10. Till 16 we can give. Also the password we can give as with the caps or small letters, numbers, special symbols, so that we can strengthen the passwords. Next is assign Cisco 12345 as the privileged exec encrypted password. Right, so we will set that. Enable secret as Cisco 12345. Next is assign Cisco ConPass as the console password. Establish a timed out, enable login and add the logging synchronous command. The logging synchronous command synchronize, debug and Cisco iOS software output and prevents these messages from interrupting your keyboard input. Right, here we can see that we are going to line console 0 password as specified Cisco ConPass, then exec timeout 5 minutes 0 seconds, then login, then we are going to give this command as specified logging synchronous. So we will configure this now. Coming to the configuration, line console 0, here we are going to set the password as Cisco ConPass. Now we will give a exit timed out. Here we can see time out in minutes, so specified 5. Then timeout in seconds, so specified 0. Also we will give logging synchronous. Next is for the exit timeout command. What do the 5 and 0 represent? Yes, just now we have seen that first number is minute and the second one is the seconds. Coming to the next, assign Cisco VTY pass as the VTY password, establish a timed out, enable login, and add the logging synchronous command. Here we can see that. Coming to the configuration, line VTY 0 to 15, password as a Cisco VTY pass, exit timeout 5 space 0 seconds, logging synchronous. Next is encrypt the clear text passwords using service password encryption. Also we are going to create a banner that warns anyone accessing the device that unauthorized access is prohibited. Right, coming to the configuration, service password encryption, and we are going to set the banner MOTD and the message. Right. Next is configure an IP address and interface description. Activate both interfaces on the router. Here we can see that for the gigabit Ethernet 0/0 we have to give the description connection to PC-B, and here we can see the IP address. It's 192.168.0.1 and it's subnet to mask. Then we have to give the no-shut command. Also we have to configure the interface gigabit Ethernet 0/1 and we have to give the description as connection to S1. Also we have to set the IP address, so 192.168.1.1 with the subnet to mask. Then we have to give no-shut command. Coming to the configuration, we have to go to the interface gigabit Ethernet 0/0, and here we are going to give the description as connection to PCB. Now we are going to set the IP address, that's 192.168.0.1. Also we have to set this subnet to mask as 255.255.255.0 and no-shut command. Coming to the next interface, interface gigabit Ethernet 0/1, and now we will set the description as connection to S1. Now we will set the IP address 192.168.1.1 and the subnet to mask is 255.255.255.0. Also we will give the no-shut command. Next is set the clock on the router. For example, clock set 17:00:00 18 Feb 2013. Save the running configuration to the startup configuration file using copy running config space startup config. Coming to the configuration, clock set 17:00:00. So we are going to set the date, day of the month 25. Then we have to specify the month of the year, December, then year. Now we will save the configuration using copy running config space startup config. Next is what would be the result of reloading the router prior to completing the copy running config space startup config command. Obviously, so whatever configuration we have done, it is stored in the RAM. So we know that RAM is a volatile memory. That means when the power goes or when the device is reloading, we will lose the RAM contents. That means the running config. So before reloading or power off, we have to copy the content from running config to startup config. Otherwise we are going to lose all the configurations whatever we have done in our device. Here we can see the running config is nothing but the RAM which is volatile, and the startup config is nothing but the NVRAM, that is non-volatile RAM. Next is verify network connectivity. Ping PCB from a command prompt on PCA. It may be necessary to disable the PC's firewall. Where the ping successful, we will verify that. Coming to PCA, before that we will see the IP address of PCB. It's a 0.3. We will come to PCA command prompt. We are going to give the ping command to PCB. Yes, we are getting the reply. Next is, after completing this series of commands, what type of remote access could be used to access R1? Yes, so we already enabled our line VTY. We can use Telnet service. Next is remotely access R1 from PC-A using the TerraTame Telnet client. Open TerraTame and enter the gigabit Ethernet 0/1 interface IP address of R1 in the host. Field of the TerraTame new connection window, ensure that the Telnet radio button is selected and then click OK to connect to the router. Here we can see the address 192.168.1.1. So we will try in our packet tracer. Coming to PCA command prompt, here we are going to give Telnet 192.168.1.1. yes, it's prompted for the password. Cisco VTY pass. Yes, so we able to access R1 with the help of Telnet. Was a remote access successful? Yes, it is successful. Why is the Telnet protocol considered to be a security risk? Yes, so if you are using the Telnet protocol service and if we are configuring any device, the configuration will be sent as a plain text. So somebody can access the plain text and they can go through the contents, they can get the passwords, and they can access the device. So this protocol Telnet is considered to be a security risk. Coming to step 4, configure the router for SSH access. Enable SSH connections and to create a user in the local database of the router. So here we can see the commands. We are going to enter these commands into our packet tracer. Coming to the configuration, configure terminal. We have to set the IP domain name as specified CCNA-lab.com. Now we are going to set the username as admin and privilege 0 to 15 user privilege level. We will give 15 as specified. Then secret admin pass 1. Now we are going to line VTY 0 to 15. Transport input SSH. Login local. Now we will give a crypto key generate RSA. Here we are going to give 1024. Next is remotely access R1 from PCA using the TerraTame SSH client. Open TerraTame and enter the gigabit Ethernet 0/1 interface IP address of R1 in the host. Field of the TerraTame new connection window. Ensure that the SSH radio button is selected and then click OK to connect to the router. Here we can see that the host address So we will try in our packet tracer now. Coming to PCA command prompt, here we are going to give SSH and we will press enter. So here we can see that SSH space -L, then we have to specify the username as we given admin, and the target is 192.168.1.1. Yes, it's prompted for the password. It's admin pass1. Yes, we are getting the router. Was remote access successful? Yes, with the help of SSH we able to access the router R1. Now we will come to part 3, display router information. In part 3 you will use the show commands from an SSH session to retrieve information from the router. Step 1, establish an SSH session to R1 using term on PCB. Open an SSH session to R1 at IP address 192.168.0.1 and log in as admin with the password admin pass1. Then we have to retrieve important hardware and software informations, right? So we will access R1 with the help of SSH. Coming to PCB command prompt, here we are going to give SSH space -L, then we have to give the username and the target 192.168.0.1. Yes, it's prompted for the password Cisco, sorry, it's admin pass1. Yes, we are getting the router. Next is step 2, retrieve important hardware and software information. Use the show version command to answer questions about the router. Here we got 3 questions. What is the name of the iOS image that the router is running? How much non-volatile random access memory does the router have? How much flash memory does the router have? Right, we will check with the help of this command show version. Here is our router. We accessed with the help of SSH. So we are going to give the command show version, and here we can see the details. Yes, here we can see C1900 software. It's a universal K9-M, and here we can see the version 15.21. So we will see the non-volatile memory size. Here we can see that 255 bytes of non-volatile configuration memory. Also here we can see 24986 kilobytes of ATA system compact flash. Next is the show commands often provide multiple screens of outputs. Filtering the output allows a user to display certain section of the output. To enable the filtering command, enter a pipe character after a show command, followed by a filtering parameter and a filtering expression. You can match the output to the filtering statement by using the include keyword to display all lines from the output that contain the filtering expression. Filter the show version command using show version, then this is a simple pipe character. Include register to answer the following question: what is the boot process for the router on the next or reload? So we will check that. Coming to our PCB SSH session. So here we are going to give the command show version, then the pipeline character include register. Here we can see that configuration register is 0x2102. Coming to step 3, display the startup configuration. Use the show startup config command on the router to answer the following questions: how are passwords presented in the output? Right, we will check that. Here we are going to give show running config, and here we can see the passwords. Enable secret, it's already encrypted because it's a secret password. Here we can see line VTY password, it's encrypted. Also we can see line console password also encrypted because we given the command service password encryption, so that all the passwords will be encrypted. Next is use the show startup config, then pipe character begin VTY command. What is the result of using this command? Here we are going to give the command show startup config pipeline begin VTY. So here we can see we are getting an error message. So usually in the real router we will get the result for this command. Next is step 4, display the routing table on the router. Use the show IP route command on the router to answer the following questions. What code is used in the routing table to indicate a directly connected networks? So we will see that. Here we are going to give a show IP route, and here we can see the character C is for connected. And how many route entries are coded with a C code in the routing table? Right, here we have seen a total 2 connected with the character C. Next is step 5, display a summary list of the interfaces on the router. Use the show IP interface brief command on the router to answer the following question. What command changed the status of the gigabit Ethernet ports from administratively down to up? We will check that using the command show IP interface brief, and here we can see that the status is up and the protocol is also up. So we given a no shutdown command for these interfaces. That's why it changed status from administratively down to up. Coming to part 4, configure IPv6 and verify connectivity. Assign IPv6 addresses to R1 gigabit Ethernet 0/0 and enable IPv6 routing. So assigning an IPv6 address in addition to an IPv4 address on an interface is known as dual stacking, because both the IPv4 and IPv6 protocol stacks are active. By enabling IPv6 unicast routing on R1, PC-B receives the R1 gigabit Ethernet 0/0 IPv6 network prefix and can auto-configure its IPv6 address and its default gateway. Assign an IPv6 global unicast address to interface gigabit Ethernet 0/0. Assign the link local address in addition to the unicast address on the interface and to enable IPv6 routing. Here we can see all that commands. Coming to the configuration, configure terminal, we have to go to the interface gigabit Ethernet 0/0. Here we are going to set the IPv6 address. Here is the address. Now we are going to set IPv6 address FE80:1 as a link local, and we will give no shut command. Here we are going to give IPv6 unicast routing. Next is use the show IPv6 interface brief command to verify IPv6 settings on R1. If no IPv6 address is assigned to gigabit Ethernet 0/1, why is it listed as up? That means the status on protocol. Right, we will check that. So here we are going to give the command show IPv6 interface brief, and here we can see the details. Here we can see the IPv6 address. Here we can see gigabit Ethernet 0/1 is up/up. So we know we set IPv4 address for this interface and we given the command no shutdown, so it shows up. Next is issue the ipconfig command on PC-B to examine the IPv6 configuration. What is the IPv6 address assigned to PC-B? What is the default gateway assigned to PC-B? And to issue a ping from PC-B to the R1 default gateway link local address. Was it successful? Then issue a ping from PC-B to the R1 IPv6 unicast address to this address. And was it successful? right? We will check all these. Now we will exit from the router R1 and coming to IP configuration. Here we are going to give auto config, and now we will check the IP address using IPv6 config, and here we can see the details. Here we can see IPv6 address and default gateway. Now we will ping to link local address of the router R1. Ping FE80:1. Yes, we are getting the replay. Also, we will ping to the given address. Yes, we are getting the replay. Yes, so here we are able to ping to R1 default gateway link local address, also to IPv6 unicast address of the router R1. Coming to the next reflection questions. In researching a network connectivity issue, a technician suspects that an interface was not enabled. What show command could the technician use to troubleshoot this issue? Obviously, we can use a show IP interface brief. In searching a network connectivity issue, a technician suspects that an interface was assigned an incorrect subnet to mask. What show command could the technician use to troubleshoot this issue? Obviously, here we can use a show running config. Coming to third question, after configuring IPv6 on the R1 gigabit Ethernet 0/0 PC-B LAN, if you were to ping from PC A to the PC B IPv6 address, would the ping succeed? Why or why not? Obviously, it won't ping. Coming to our packet tracer, here we can see we assign the IP address for this interface gigabit Ethernet 0/0, but we did not set IPv6 address for this interface, that is gigabit Ethernet 0/1. Next is Appendix A, initializing and reloading a router and switch. Step 1, initialize and reload the router. We are going to erase the startup config, then we are going to reload our router. So here they will prompt for system configuration has been modified, save. We have to give no. So we will try this on our router. Coming to the router, CLI, enable Cisco 12345. Here we are going to give the command erase startup config. Now we are going to reload. System configuration has been modified, save, no, confirm. So would you like to enter the initial configuration dialog? No. Here we can see the router is now in its initial state. Coming to step 2, initialize and reload the switch. So we are going to check the flash. Then if this file vlan.dat file exists, we are going to delete that file. Then also here also we are going to erase the startup config and we are going to reload it. Coming to our switch S1, CLI. Here we are going to check show flash, and here we cannot see any vlan.dat file. So we are going to erase startup config and we are going to reload. Confirm. Here we can see all the configurations had been removed. Now the switch, here we can see the switch name is a default switch name, So all the configurations had been removed. Yes, that's all in this lab activity, that is configuring basic router settings with the iOS CLI. Friends, if you have any doubt, please comment below. Also, if you like my video, give a thumb. And don't forget to subscribe the channel so that you will get latest uploading video info into your mail. Thank you.